So here we are looking at two shapes. Sector of a circle, meaning a part of a circle, not a full circle, and triangle. They usually, and anything that has to do with circle often goes with triangle. Let's see. Dermot has a logo of an ice cream cone on the side of his van. And we can see the logo. This is the part of ice cream, and this part is a cone. The logo is made up of a sector of the circle, so that part is the sector of the circle with radius 20. So that's here, that's my radius 20, and two identical right angle triangles. So this triangle and this triangle are exactly the same, and this is where we have right angle in them. The arc of the sector is labeled S, so that is the arc of the sector, part of a circle. The size of some angles are shown, and yes, we have here 70 degrees and 70, and that's the right angle. So what do we need to do? Find the size of the angle theta, so that's where my theta is, so I need to find that, and hence, meaning what? With that knowledge, we will be able to do what? Find the length of the arc S. So two things to do, find the size of the angle and find the length of the arc. So how do we do that? Well, all of that here, that's a circle, isn't it? And circle has 360 degrees. So if from 360 degrees we take away these two, which is 70 and 70, therefore we are left with this part. And again, if we put it in the calculator, press equal, we get that that is 220, so that's our theta. Now, enhance with that knowledge. So knowing what that angle is, we're going now to be able to find the second part, which is the length of the arc. And how do we do that? Well, we go to our maths tables where we have the sector and the arc. And here we can see the arc is L, and then we have the theta, the angle, and R is the radius. So L, that's the arc. And here we can see that there are two different formulas for L. So which formula do we choose? So beside these two formulas is written when theta, meaning the angle given to us, is in radians. And then the second two formulas is when that theta, that angle here, is given in the degrees. So our angle is in degrees, so therefore this is the formula we're going to use. Now, don't forget that when we have no sign between letters and numbers, we have what? Multiplication sign, isn't it? So in this case, our arc is not called S, L is called S. So S equal to multiply by pi, multiply R is the radius, and our radius was 20, multiply by a fraction. On top of the fraction is our angle. Our angle is 220, and divided by 360. And therefore, we put all of that in the calculator, and to one decimal place, we get that is 76.8 centimeters. Okay, let's have a look at the second part of this question. Use trigonometry to work out the length of the side label L. Give your answer correct to the nearest centimeter. So let's just get our cone here so that we can see that. So we are looking for what? We are looking for this length. So again, they did point to us that we are dealing with triangle here. So when it comes to triangle, what are our options? Page 16 in our maths table, when we are dealing with a right angle triangle, as we do here, it is right angle. We know we have two options. We have Pythagoras and trigonometric ratio. Now, here they are pointing us towards trigonometric ratio, but not always they do. So if they don't, how do we make that choice? Pythagoras, the formula here, where is it? Let's get that. No, that's not the formulas. That's the area. There it is. So these are the formulas here. So when it comes to Pythagoras, this formula here, the C, the A, and B, C, A, and B, all of that are the sides of triangle. So when it comes to Pythagoras, we are having three sides. Now, when it comes to trigonometric ratio, the three of them, each of them have capital A, and we can see capital A is an angle, so angle is involved. and then two small letters. And small letters, as we can see, they are the sides of the triangle. Now, what information do we have here and what are we looking for? I am looking for L, and L is what? A side of the triangle. So I'm saying, okay, side, I'm looking for that. What information do I have? I have 20 here, which is a side. So I have 20, I have side. And then here in this case, I have an angle. So that's the reason why they are pointing us to trigonometric ratio, because this is where we have all the information. Now, the question is it sin? Is it cos? Is it tan that we're going to use? Okay, so A and C and B and A, where is that in our triangle? How do we know? Well, we always start with an angle. So this angle is the angle that is given to us. Therefore, this angle, we're going to say that's the capital A. Now, as you can observe in your table, opposite that angle, you have small a. That means opposite that A, that will be the side A. Then the next reference point is the right angle, the side that is opposite the right angle, that is C. So this is where we have our right angle, and the side opposite is this one, so that is C. That is leaving us with the last one, B, so that is my B. Now, what am I looking for? L. So in my formula, I need to have small a. I have small b. I have capital A. There is no point for me to choose a formula that have C because I don't have C. So then I'm looking these three letters. Which of those three formulas have these three letters? Have a look. And yes, spot on. This is the one that have our letters. So it's tan we're going to use. So that means tan. We write the formula down. We are showing that we know which formula to use. And next thing, we replace those letters with values from our triangle. So tan, our angle A is 70, equal fraction line on top of the fraction is A. Our A is L, so we put L. On the bottom of the fraction, we have B. Our B is 20, we put 20. Now, what do we do next? What do we want? We want L equal a number, not L divided by a number. How do we get rid of that bottom of the fraction, denominator? Always the same, by multiplying. If we multiply one side of the equation, we have to multiply the other side of the equation, because 20 divided by 20 is 1, and 1 multiplied by L is L. Therefore, 20 multiplied by tan of 70 will give me the length of L. We put that in the calculator, and to the nearest centimeter, we get that this is 55 centimeters. That is the length of L.